Our session today, we will look at correlation analysis. So we must understand that when we are dealing with relationships, it is vital to comprehend how these relationships really align, whether they are positive or negative. Under correlation analysis, we are going to look at relationships that emanate from three different angles. So we will have a positive relationship that could either be strong or weak. If the dots are close, correlation is strong. You can also have a negative relationship, which is like the demand curve. You can have a strong negative relationship, and you can have no relationship at all with a horizontal line. The relationship can again be positive, yet weak with the dots apart from each other. You can have a negative relationship with the dots apart from each other, which are weak. So correlation analysis is very important when we want to deduce relationships between the dependent variables and the independent variables, X and Y. Correlation analysis is important when you're dealing with research studies, understanding how causality comes to being, how much of X influences Y. And so in this segment, we must understand how to come up with a regression equation, which is given by A plus BX. And we can also understand our R, which is a coefficient of correlation, which is given by our N summation of X, Y minus summation of X times summation of Y over the square root of the variation in X and the variation in Y. So this is the key principal formula in correlation analysis. So the relationship can be strong, the relationship can be weak. So we want to understand how much of X is affected by Y, and also we want to understand whether these relationships are positive or negative. So this is the simplest topic in this course, but requires a lot of your attention. So these are the key formulas that you must understand. Of course, they're given, but I really just need you to have them at your fingertips. If I can know them, you too can know them. So R stands for the coefficient of correlation. Our key interest here is whether the relationship is positive, whether the relationship is indeed negative. So a positive relationship denotes that X and Y are directly related. An example of a positive relationship is supply. It is upsloping. We can also have a negative relationship, which is an inverse relationship. An inverse relationship simply signifies that as variable X is going up, variable Y is going down. So this inverse relationship is important to understanding. Also, you must understand that you can find the strength of the relationship by squaring your answer. R squared simply denotes the strength of the relationship. It measures how much of X is affected by Y. Your R squared could be more than 50%, meaning it's a strong relationship, or weak relationship if it's less than 30%, 20%. So between 20 and 50, this is a moderate relationship. Okay, are we together so far? You need to understand these components before I proceed. Any questions so far? So between 20 and 50, that is a moderate relationship. Less than 20, that is a weak relationship. Correlation analysis is very important in many applications. So we'll look at an example where correlation analysis will be applied. So correlation analysis, for those that have joined, is a statistical method that we use to measure the strength and the direction between two variables. So if one variable changes, how does the other variable change? That's what we're looking at. We want to understand whether the variables are related. Are they positively related, negatively related, or no relationship at all? We want to understand if this relationship exists. Is it strong? Is it weak? Is it moderate, or there's no relationship? And also using the regression equation to predict the um, relationship through this model. Okay? So relationships can be positive when both variables move in the same direction. Relationships can be negative when one variable increases, the other one decreases. Relationship can be none when there's no relationship at all. So we use what we call a scatter diagram, a plotting method where one variable against the other will indicate a type of relationship, whether it's up or downward sloping, or a random scatter. A random scatter is one which has no direction, meaning there's no relationship at all. This is a random scatter. The formulas I've given you there. So our regression, our error should range between 0 and what? And 1. Okay? Should be positive. So if you have a positive 1, it's a perfect positive relationship. If you have 0, there's no correlation. If you have negative, it's a perfect negative correlation. So coefficients, if you have between 90% and 100, very strong, 70 to 89, strong, 40 to 69, moderate, 10 to 39, weak, 0 to 9, very weak. Okay, so these are the key points you need to understand. So if you're given X and Y, this is 1, 2, 3, 4, and 5. You can have 1, 1, 2, 2, and 4. So you can sketch these and tell from the relationship what type of relationship this is. So let's sketch and be able to tell this is our Y, this is our X, this is our 0, this is our 1, 2, 3, 4, and 5. So 0, 1. Are we together?
Yes, I will.
So you are able to sketch this on the X or Y plane. 1, comma 1, we part here. 2, comma 1, put it here. 3, 2, put it here. 4, 2, put it here. 5, 4, put it here. So from the look of things here, what type of relationship is this? So this relationship is showing that there's a positive relationship which is strong. Okay, then you can go ahead now and prove whether it is really positive and it's really strong by calculating it. So we have xy, we have x squared, and y squared. Let's fill in the blanks together. What is our x squared? So here I have 1, 2, 6, xy, we're just multiplying here, 8 and 20. And y squared, here we have 1, 4, 9, 16, and 25. And on the other hand, here we have to square these ones individually, 1, 1, 4, 4, and 16. Then you total up here. This is called the summation of x. This is called the summation of y. This is called the summation of xy. This is summation of x squared. And this is summation of y squared. So we total up here. We are going to get summation of x squared or x, what are we going to have here? 15, 10, 87, 55, and 26. So having totaled in that column, you'll be asked now to calculate what is your regression equation, what is your relationship R squared and R. So in that case, you just need to substitute in the formulas that have been given. So our n in this case is what? 1, 2, 3, 4, 5. Our n is 5. So what is the correlation and what is the strength of the relationship? And so our n is 5. So we substitute in this column here to find our R. So R is equal to what? 5 xy is 37 x times y. X is 15. Y is what? 10 over the square root. N is what? N is what? Still 5. And the x squared is what? 55 minus x to the power 2. So 15 squared. Then y, our n is still 5. Then y squared is what? 26 minus y to the power 2, which is 10 squared. So our R, when you calculate properly, we're going to get 0.903 just from the sign. What type of relationship is this? You can say it's a positive relationship. This is called the coefficient of correlation. Coefficient of what? Correlation. So be careful in substituting that. The calculator can also do this for you. You just go to If it's a Casio, uh, mod 21, then you start entering them. 1, 1 m+. So I'll take you through the calculator way on its own, but I'll send you a video just on entering these alone. So this is called the coefficient of correlation. What does it tell you? It has a positive or direct relationship. X and Y are directly related. Then when you square this answer, R squared, just literally squaring this answer, 0.903 to the power 2. What do we get? 0.8116. It means at 1.6%, just multiply by 100. At 1.6% of X is as a result of Y. Okay? At 1.6% of X is because of Y. At 1.6% of Y is due to X. Y is the result, X is the input. So we have what we call the independent variable and the dependent variable. So we have done the correlation. Then we can also calculate the regression equation itself and predict whether our Y. So we can tell that the relationship there is strong. Like I said, if you have what? A correlation of as follows: 90 to 100, that is what? Very strong. 70 to 89 is strong. 40 to 69 is moderate. 10 to 39 is weak. 0 to 9% is none, no relationship, or very weak. So we now want to calculate the regression equation. Y is equal to A minus BX. So A plus BX. We can start with B before calculating our A. The formula for B, which is a gradient, is N summation of XY minus summation of X and summation of Y over N summation of X squared minus X to the power 2. So in this case, our N is what? 5. XY. So similar to this and the green one only. So 5, it's 7 minus what? 15 times 10 over that square rooting 5 times 55 minus 10 squared or minus 15 squared. So when you calculate that, you're going to have what? Our B to be 0.7. Then our A is simply summation of Y over N minus B summation of X over N. So summation of Y is what? 10 over 5 minus the B we've just calculated here, 0.7. Then summation of X is 15 over N, which is 5. So when you calculate this, I hope you are following. Our A will be negative 0.1. So we found A and B, we simply substitute. So meaning our regression equation therefore will be y is equal to, where there's a, we put -1, 0.1, and b, we put 0.7 since we calculated it, and the x. So this is 3 marks. Calculate the regression equation. So they'll then ask you now find y when x is something, be 10. Find y when x is 10. So substitute where there's x, you put 10. So you can say y is equal to negative 0.1 plus what? 0.7 x. So where there's x, you put 10. Yes, is that a question?
Okay, okay. Oh yeah, just that because I saw some questions where they will say maybe they'll put months, say 11 month, the 12 month, you just add X the following month where you put in that event when in a scenario where they will ask for people to say 11 months, then what is the 12 month?
Yes, exactly. They'll ask you to predict. Okay?
Thank you so much, Mr.
Okay, so now we let's try to look at an exam question. Any questions? Anyone behind so far? Before I give you some homework. Are we together? Any anyone behind?
Yes, we are together, sir.
Okay. So I need
I think for me, Mr. Collins,
yes, yes.
just to take you back, just take you back. I think I joined a little bit late. On X and Y, uh, these are the digits that you have put here, the numbers one, two, three. Maybe you can just verify Y.
So the numbers we've been given here are usually given in exam setting. Okay. For
Okay,
instance,
so X can be, oh, I see. X can be maybe months. Oh, I
yes.
see. Okay,
So a
okay.
question can come like this. Okay.
Oh, yeah.
This
Okay.
regression
Yeah, that was
equation.
clear.
I'll give you any kind of number. So just check the pamphlet. You already have this one on page 93. Okay. You've been given your X and your Y. Sometimes you need to actually identify which one's your X depending on causality. Because you need to
Okay,
understand
okay. So
who is
then,
which one is the result and which one is the input. So in terms of understanding, you also need to understand how to determine the X and Y variables, which one is a dependent variable and which one is our independent variable. So in correlation analysis, these are very important. The X variable is what is called the independent variable. It's also called the explanatory variable. It is simply the variable that you want to change, you can control, and how it affects the other. It's assumed to influence or to explain the changes in Y. Okay? For instance, advertising is the input, sales the output. So Y is the dependent variable. It's also called the response variable. It is a variable that changes in response to X. So it depends on X. So on the graphs, we put it as Y. So these are very important. So in this case, management score and point average grading. So you needed to know which one is your X and which one is your Y. So the grade point average was our Y and the management score was the X. Then you sketch it like this. All right. Here you're given the week and the number of cells. You're asked to do the regression equation. So you're also asked to estimate the expected cells in the 7th week. So if our X is 7, then you calculate your Y. So this will be your homework, which I expect. All right. So you check on page 94. Please attempt this. Our next class will be on
Thank you. Thank you
hypothesis
so much.
testing. Then we'll look at probability. Thank you so much for your time. Have a good day.
So, thank you so much.